Okay, we're approaching the thing that is most difficult for most students, and that is dealing with logs. And I made this little sheet to help you with that issue. We're going to look at, first of all, what gives you the more part of the pH. And the more part of the pH is always going to be, so this number right here is defined as a logarithm when the number is an exponent of 10. And the logarithm then of this is minus 2, right?
Yes.
But
Yes.
we have the minus out here, which changes that sign. Minus times a minus is a plus. So that's why this guy has a positive value. And same thing here. Now, if I do the minus log of something that does not have, here, let's get this guy up here. And let's get a line here. There we go. Slower. Okay, I can deal with that. You want it slower? I can do it slower. Now, here with the minus log of this number, which is say 2.6 times 10 to the minus, let's try 8. Minus 8. Okay, we have two components. We have this guy that has to be taken a log of, and we have this guy that has to be taken a log of. When we did the log over here, the log of 1 is 0, so it has no effect on the value when we wind up with just plain old 2. We put the number out here, and this is in essence telling us how far we are between the log of 10 to the minus 8 and the log of 10 to the minus 7. It's a little strange. We'll get it. So what we're going to do is, first of all, we will start out with the minus 8 part. That becomes a plus 8. Now we got to deal with this guy, which you're going to need a log chart for. So this log chart is going to be used in this fashion. So the number that we had is in this range, is it not? Yeah, 2.6. Oops, went the wrong way. 2.6 is between 2 and 3. We are going to give that number an estimate of 0.3. Actually, I'm going to move that up, so we're going to use a different thing. That's the same as the example over here. We have 4 to 6 range. Let's change that just to make it different. And let's make this 5.5. Okay, so back here, 5.5 is between a 4 and a 6, is it not? Yeah? So that value as a log is 0.7. Let's go back here, and 0.7 is going to be the number that I am going to subtract from here. And what is my number? 7.3. Okay. So this is really all there is to it. It's just taking one of those three estimates and using it in bringing the 8, there we go, bringing this 8 down to a 7.3, because we are half of the way in this numeric system between a 1 and a 10. And when we go to 10, this number is going to get bigger, or smaller, I'm sorry. Yes?
The 8.0 is the exponent, right? What is the exponent?
8.0 was the exponent with the sign changed, because it was a negative log. Just the plain log of this would be, yeah, right, it would be a negative 8. So,
Oh, it's negative to a negative.
right. So what I say is, don't worry about negative times negative, just say change the sign. And that makes life easier. So let's go back now and do another example. Same deal. This 5 here is a logarithm. Okay? It's a log. That 5 is a log. And this 8 here is a log. And this is a log. Yeah? These aren't real numbers. Okay? Not real numbers in the way that you think of them. Okay, so we're going to take this log now, and we have a number, oops, here you go, 2.3 that we need to worry about. So when we come over here, the 2.3 is between the 2 and the 3, right? And so that is a 0.3. And that is where this 3, the 0.3 here comes from. And let's just take this guy and point at him. So my 0.3 is going to be subtracted from the 5.0, and that gives me a pH of 4.7. It's making some kind of sense, I hope. Next thing I think would be very valuable for us to do is take these are going to be numbers to the left of 10 to the x. So whatever 10 is, whatever the power of 10 is, I'm going to make those powers 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now watch what happens. Let's take a real number and let's put an underline here times 10 to the minus 11. So here we go. I'm going to have the number be 1. When the number is 1, the log of 1 is 0. Okay, if I make this number 2, let's go back to the chart now, because 1 is not on the chart, is it? No. Okay, so if I make the number 2, what's my estimate? 0.3. Okay, so would you guys look at the chart and I'll fill it in, okay? 0.3. What do we have for 3? 0.3. What do we have for 4? 0.7. And 5? 0.7. 6? 0.7. And 7? 0.9. And 0.9, right? Whoops. This guy should have moved over. Oh well. I'm going to have to erase it. That's okay. 0.9. So those are my estimates, right? 0.9. Oh boy. 0.9 here. 0.9 here. And is 9 in the chart? Okay. So that's also 0.9, isn't it? Okay. Now what happens when I go to 0? Or when I go to 1, I've got a 0, so I don't need to worry about it. At 10, instead of 0.9, we're going to have, what?
1.
1. And when we get to 1, what do we have? 0 again.
0.
Okay? But if we have this guy being, if this guy is a 10, watch what happens here. 10 times 10 to the minus 11. I'm no longer in scientific notation. Correct? Okay. So, now this is going to become 1.0 times 10 to the minus what?
10.
It's 10, isn't it? The number went down. See, when this guy goes up, this is actually being taken away from. We're chewing away at it, at its value. And now we have minus 10. now the reason that makes sense is because a bigger negative number is a smaller number, isn't it?
Yeah.
Isn't this a smaller number than this?
Yeah.
Yeah. Okay, so when we get up to 10, we've got to roll over, so to speak, and that takes us, you see, from 0.9 to 10, or to a 1. And when we have a 1, we don't need to worry about the number out front because it's not going to be subtracted from the number that we get from logging this, is it? Did I make sense with that?
Yes.
I hope. So you can see that this progression as we go up here is actually bringing the power of 10 down because it's making the number bigger, isn't it?
Mm-hmm.
Yes.
Let's say the number is 3.5. Can you still round to 0.3? Or
You can do it any way you want. It won't matter.
it won't
Because
matter if we round to 0.3?
the reason it won't matter is this guy is giving you 90% of your accuracy. When we estimate anything in between 10 to the minus 11 and 10 to the minus 10, that's what these numbers up here are all about. See, this row right here is where we have the numbers that would be in here. All right, so we're substituting this number here, and we get 0.3. Okay? Did I answer your question?
Well, kind of. The reason I asked that was because on this here, one of the examples, I'm using this sheet with your estimates. It was off by 0.5.
Yeah,
So it's fine
right.
given-
Remember I told you your accuracy is 90% by the time you take the log of this guy.
So does that also mean that on our test they're usually off by a bit? Or
Oh yes, of course they'll be off. You bet they'll be off. Yeah.
So our on test. we
And you
should-
can estimate it better. Take the numbers in between. And just kind of work it out a little bit better. The more numbers you put in between, the more accuracy you'll have. Like this guy could be, I'm trying to keep it really simple without giving you a whole log table. Okay, so the numbers over here work out to be 2 or 3 is a 0.3. So we would say, well, if it's a 2, why don't we call it 0.2? And if it's a 3.5, let's call it 0.4. And if it's a 4, let's call it 5. And if it's if we get up to a 5, let's call it 6. And when we get to when we get to the 6, we're at 7. But you can see what I'm trying to do. This thing's driving me nuts. I got to nail this guy down so he doesn't move. There we go. That's where he belongs. Let's K him. There we go. He won't move on me again. Okay, so in here, you see, I could put numbers in between, and that would be perfectly valid. And you'll notice that they don't really progress on a one-by-one basis. Okay, you can see that as we go from one to another. And you can get a log table on the computer anytime you want. And you can look at the actual numbers that go between 0 and the 10. And you'll see what they work out to. And so that's kind of interesting. So to summarize, this kind of a problem requires no estimating. And who can tell me why? Anybody tell me why? Why doesn't it require an estimate? Go ahead.
It's 0.
Yeah, the log of 1 is 0. That's why. That's why. Log of 1 is 0, so nothing has to be subtracted from this dude when we turn this into a number, or when we turn it into a log. The 10 to the minus 4 becomes the log, and we change the sign so it becomes a plus 4. And when I subtract 0, it's still plus 4. Right? So when I get logs between 2 and 9, then I've got to do some estimating. And you just get close. And you'll get close enough to be able to answer questions on any test.
So this is the homework tonight?
Your homework tonight's going to require that you be able to do that. And now let's look at one more example here. Okay, on this example, we've got 6.2. So 6.2 times 10 to the minus 11. 6.2 is where on this scale?
0.7.
0.7. Okay. So that's why you see right down here the 0.7. Are we good?
Yeah.
And he's a negative. Why is he a negative? Because we're still doing a minus log with this guy. So when we minus log, we come out with 0.7 and change the sign. So he's a negative. I didn't figure that out till this year. Anyway, so it's something that will give you a great deal of help. Let's go and look at another example. Here we go. This is more like your homework. Okay. Looks complicated. Not so.
Why so easy?
Not so. Not so. So, okay, first of all, let's focus on the 6.3 part. Actually, we'll focus on this guy first. Okay, this is always our first number. He's always a number that's going to be bigger than 1, right?
Yeah.
Okay, so that's your 4-0. 6.3, you know that came out to, what, a 5?
What?
No, it was a 7. 6.3 on our estimator gave us a 0.7. When we subtract it out, there's our pH, not our POH. Okay, so how are we going to get the pH? Ah, that's our baby. Yes, sir, that's my baby nose, sir. I don't mean maybe. Yes, sir, that's my baby now.
That's not in my time.
Anyway, I know I'm recording. So, at any rate, the whole world now knows I'm crazy. So, if I give you the pH, can't you find the POH? Yeah, subtract from 14. Okay, this time I wound up with POH, right? So let's label it as such. This is the POH because I was given hydroxide ion concentrations, right?
Yes.
So whether it's hydroxide or hydrogen ions, doesn't matter. The calculation is the same. We just call it something different. Okay? We're going to take the log of the exponent, which is just the value of the exponent, with the sign changed. Then we're going to take the log of the number out front, change the sign again because that's positive. It will be a negative, and so that's my minus 7. And so now the POH is equal to 3.30. Now, I subtract 3.30 from the pH, and the pH is equal to 10.7. Because I'm going to subtract the 3.30 from the 14. All right?
Oh, I added another.
Yeah, okay, that's why you got a different number, isn't it?
Yeah.
Okay. All right. Basic algebra. Yeah. Okay, here's that little thing again. Let's go in and look at this problem. Here's the hydrogen ion concentration. Find the POH. Same kind of deal, isn't it?
Yeah.
Only let's change it this time. Let's call this guy the hydroxide. Did I give you hydroxide last time?
Yeah.
Okay, good. So this is different. All right. So we got 4.9 times 10 to the minus 2. Find the POH. Well, we've got to take our minus 2.0. Here we go. So the 10 to the minus 2 gives us the 2.0. This guy comes from our estimator, right?
Yeah.
We look up 4.9 on the chart in the left-hand column, and we change that to the logarithm, which is 0.7. Subtract them out, we get 1.3. This is the pH. How many of you think you can find the POH now? Would you all do that?
Wait, I'm still doing it.
Okay, do the POH now.
Wait.
You got the pH. Find me the
Wait,
POH.
1.3 plus POH equals
Yes, equal 14.
12.7.
12.7.
There you go.
You didn't hear him.
Okay, 14 minus the 1.3 gives you your POH. And there's your answer. Nice, huh? Because the pH plus the POH is equal to 14. That's the biggie. I think that's it, folks.
Yay!
Yay.
Yay! I can't be in here.